I'm sure everyone has heard on the news lately, privacy is a big deal. And if people hand over their data, they're going to care a whole lot about what happens to it and how that data is going to be used.
Hi, my name's David Morrison, one of the co-hosts of Originals, where we present outstanding research in everyday language. Today, I'm excited to introduce you to Rachel Cummings, a PhD student at the California Institute of Technology. She's going to talk about her research using the field of algorithmic game theory to inform privacy and security on the internet.
Hi, I am Rachel Cummings, and I'm a PhD student here at Caltech. I'm in the Computing and Mathematical Sciences department here, which pairs together theoretical computer science and applied math. So my general research interests are in the intersection of computer science and economics, in a field often called algorithmic game theory. So I personally am very interested in how privacy-preserving algorithms or computational tools can be used to solve economic problems. Game theory studies the way people interact when they have some incentives. And their payoff is going to depend on their choices and also on the choices of people around them. For example, when you use Google Maps and you put in your home and your work location and you ask them for directions, they're going to give you a route that depends primarily on traffic conditions. But those are computed using everyone else's data of their car, location, and how fast they're driving. Your payoff is going to be how quickly you get from home to work. And that's going to depend on your choice, which is the route you take, but it's also going to depend on the choices of a whole bunch of other people, namely which routes they take, which is going to in turn decide the traffic conditions. There's probably a whole bunch of people who are at the same time asking for directions from their home to work. And so this computation of the optimal traffic routes has to be done quickly. It has to occur within a fraction of a second for the time that you type in information into your phone. So you might worry that your direction and your speed can be somehow leaked into other people's directions that they're given. So here's an example where privacy-preserving algorithms can be used to compute optimal traffic flows in a privacy-preserving manner. So there's two goals. One is that this computation has to occur quickly, and it also has to give some kind of a privacy guarantee to the players or the individuals who are sharing their data with this computation. So these privacy-preserving algorithms promise essentially that if one person changes their information, it's not going to change the computation's output too much. So in the example of traffic, it's saying if you change your home or your work location, that won't really affect anyone else's traffic route by too much. And so in general, these algorithms provide stability of the computation, because it says if you have a few weird people saying weird things, often called outliers, so if you have a few outliers, then it's not going to give you a very different result. And this is a desirable property in computations in general, regardless of privacy concerns. There have been a lot of pretty famous privacy violations that have occurred in the past. And if you go online and you search for them, you'll find a whole bunch. My personal favorite is known as the AOL search logs release. So many years ago, AOL released anonymized search histories of a lot of their customers for data scientists to use in their research. And they took off all of the personally identifying information about each user. So they took off their name and their geographical location and all the other information they had collected about these people, and they gave them random IDs instead. But the problem is, if you think about the kinds of things you search, the actual text of your search term, they leak a lot of information about you personally. I know I live in Pasadena, and so I search a lot for Pasadena weather, Pasadena shops. And I very often search myself. I search my own name. And so these things, even if they take off my personally identifying information, the text of my search terms actually leak a lot of information about me. There were some papers published that were able to take these search terms of a lot of AOL users and uniquely match them back to a particular individual. As a privacy researcher, I hope that these algorithms I design will eventually be used by real companies who are actually doing computations on the private data of individuals.